So how many of you have heard about Ethereum? All of you? Okay. So this is where the smart contract development happens. Bitcoin also has smart contracts, but those contracts are used only for transferring money and nothing else. So Ethereum is a blockchain platform for building decentralized applications, as most of you seem to know. So the main idea is that the application code and state is stored on a blockchain, and the transactions will cause the code to execute. So like you have a program and you have some functions. So to execute a function in that code, you have to actually launch a transaction, and then you will also the transactions will update the state which is stored on the blockchain. They will emit something called events, and they will also write logs. Then there are front-end web interfaces that which can respond to events, and they can read logs. And it is the most popular smart contract platform right now. It gained a lot of popularity in 2017 when something called initial coin offerings, ICOs, became popular. You could easily create a new token on Ethereum, and then to buy that token, people could send Ethereum to a contract, ICO contract, and they could receive the new token in response. So it is very popular. Around I think $7 billion in 2017 were invested in initial coin offerings. Then also last year, non-fungible tokens became very popular. Non-fungible tokens, typically you might have seen that there's like some kind of an image associated with it, and they're sometimes very expensive, and you keep hearing news articles about how people got rich by selling non-fungible tokens. And also decentralized finance. So you have these smart contracts which have logic for doing like flash loans and so on. So decentralized finance also became very popular. Sorry for the typo there. So the history of Ethereum is, so it was proposed in 2013. So the founder or the co-founder, Vitalik Buterin, was 19 years old at that time. So he visited the Mastercoin team. So Mastercoin was a team which was trying to add extra functionality on top of Bitcoin, and he proposed a bunch of changes, but the Mastercoin team was reluctant to make those changes. So he said, okay, I'm going to start a new project called Ethereum, and he released the white paper in 2013. He gave a list of functionalities which Ethereum will have, and he announced it in this popular forum for Bitcoiners called Bitcoin Talk in 2014, and a bunch of other people also joined the effort. They also wanted to be part of developing Ethereum, and they got together and they say that, okay, we need money to make this happen. So they said we're going to have a pre-sale. So in the Bitcoin protocol, all coins are created through mining, but Ethereum said that we need money to get this protocol off the ground. We need to pay developers, people to work on it full time. So they said that they told the Bitcoin community that you pay Bitcoin to us, and then we will give you Ethereum in return. And if Ethereum becomes popular, then you will get a return on your investment. So in some effect, this was the first initial coin offering in cryptocurrency history. So they collected a bunch of Bitcoin, and then they also created 12 million Ether. This ETH stands, BTC is of course Bitcoin, and ETH stands for the symbol for Ethereum. It's called Ether, the currency in Ethereum. So about 12 million Ether was created to pay early contributors and set up a non-profit foundation called the Ethereum Foundation, which is still in existence today. So the first release of Ethereum was July 30th, 2015. So from the time of his announcement, if you see, it's about 2.5 years. And on September 15, 2022, this year, it switched to proof of stake. So the initial version of Ethereum was proof of work. And incidentally, the Trust Lab was inaugurated on that day, on September 15th. So that's a nice piece of trivia there. So here's a comparison of Bitcoin and Ethereum now that you know something about Bitcoin. So the specification of Bitcoin, there is a Bitcoin white paper, but it does not go into the details of the Bitcoin protocol. So there is one implementation of Bitcoin called Bitcoin Core, which is a C++ implementation. It is available at the GitHub organization, Bitcoin GitHub organization. And whatever that implementation is, that is considered the specification. So if it has any bugs, then those bugs are also part of the specification. But on the other hand, the Ethereum specification was specified by Gavin Wood, he is one of the co-founders of Ethereum, in the Ethereum yellow paper. So why is it called yellow paper? For some reason he made the background color of the paper yellow, maybe to distinguish it from white papers. So that's why it's called the yellow paper. And so the consensus algorithm is SHA-256 proof of work for Bitcoin, and it's proof of stake now for Ethereum. So the contract language is for Bitcoin it's script, Bitcoin script, and for Ethereum it's EVM bytecode. EVM stands for Ethereum virtual machine. So if you have heard about Ethereum, you might have also heard about something called Solidity. So Solidity is a high-level language which compiles to EVM bytecode. So the Ethereum node itself, it runs EVM bytecode. It does not parse Solidity. So Solidity, and there's also another language called Viper, which is a Python-based language. So Solidity and Viper are high-level languages. It is like C and C++ get compiled to assembly. So in the similarly, Solidity and Viper get compiled to EVM bytecode. But the contract language in Ethereum is EVM bytecode. That is what runs on in each of the Ethereum nodes for deciding the contract actions. So the block interval Bitcoin was 10 minutes, and I think Satoshi Nakamoto chose the large interval to make sure that there's not too many forks. If you have a very short block interval, then the chance of two miners or miners not hearing about the other blocks becomes high. But Ethereum took that risk. They wanted a smart contract platform which had a good user experience. So suppose I am interacting with some application. To make any change in the Ethereum application, I have to send a transaction. Sending a transaction, the transaction has to be included in a block for it to be valid. Now if that takes minutes, then the user experience is not great. So they decided about some 15 seconds. Now it has come down to 12 seconds. So the interblock time is about 12 to 13 seconds. And but what about miners finding blocks at the same time? When there was proof of work, in Ethereum proof of work, they had this notion of uncle blocks. So if a miner finds a block which is the descendant of a previous block, they also would get some reward. They are called uncle blocks. They were actually called Omer blocks. Omer, O-M-M-E-R, is a gender neutral term for uncle or aunt. So Omer blocks would pay the miners who found blocks. They are not part of the main chain, but they also will get some reward, which is a fraction of the main block reward. The block size limit is, so I should not say limit, the block size is approximately, in Bitcoin the limit is on the block size approximately 4 MB. The block size in Ethereum has fluctuated from 69 KB to 82 KB. It's not a limit. Ethereum uses something else to limit the size of a block. It uses something called a gas limit. So each operation in the Ethereum virtual machine, it has a cost called a gas cost, and Ethereum blocks have a gas cost of 30 million gas. So as long as the block, the total amount of gas consumed by a block is less than 30 million, it's a valid block. But that block size, the gas limit, it translates to a variable block size of 69 KB to 82 KB. So the currency supply, of course, Bitcoin is fixed but variable for Ethereum. So I just checked on a few days ago, it's about 120 million Ether right now. The currency units, instead of Satoshi, they use something called Wei, and 1 Ether is 10 to the 18 Wei. So the Ethereum architecture, like I said, was specified in the Ethereum yellow paper by Gavin Wood. It is implemented in Go, C++, Python and Rust. By this I mean the implementation of the Ethereum protocol itself. And the yellow paper models Ethereum as a transaction based state machine. So you have a state sigma at some time t, and then you have a transaction, and the transaction reaches the Ethereum node, or it's executed by the Ethereum node. The new state is sigma t plus 1, and this epsilon, this symbol, is just a transaction level state transition function. So you have some state, and each transaction will change the state to some sigma t plus 1. So what is the state? So what is this state? What does it refer to? So it is it's called the world state in Ethereum. It consists of something called accounts. Each account has an address. It's similar to Bitcoin address. It's an address, and there is an account state associated with each address, and just the whole world state is just a list of accounts. It's like a very large list of accounts. But that list is not maintained as a linear list. It is maintained in something called a Merkle-Patricia trie. A trie is a tree which is optimized for information retrieval. So the word trie comes from this part of retrieval. And Patricia is a particular kind of a trie which the person who proposed it, he wrote a paper, and the name of the paper was Practical Algorithm to Retrieve Information Coded in Alphanumeric. It's not the name of any person. It's just an acronym for this phrase here. And Merkle, in the sense that the tree nodes are hashed to generate a root hash. So you have this world state. I'm not going into the details in the interest of time, but just think of this world state as being stored in a tree structure, but the leaves of the tree are also hashed, and you have a root hash, and the root hash will represent the whole world state. So if you fix the root hash, you have fixed the world state. You cannot create the world state, recreate the world state from the root hash, but once you fix it, you cannot modify the root. You cannot modify any component of the world state without modifying the root hash. So what is in an Ethereum account? So I said account state, right? So what is it account state? So there's only 4 fields actually, but let's look at the types of accounts first. There are 2 types of accounts. One is externally owned accounts. They are controlled by private keys, and the other is contract accounts. They are controlled by contract code. And an address, it will have 4 things in it. This is the account state. So the account state has 4 fields in it. One is nonce. So I did not mention it previously. Nonce stands for number used once. So it is just like a counter in this case. It is just an integer, and it is supposed to be used only once. And then there is a balance. This account, this holds the ether balance. How many coins are held in this account? Then there are 2 fields, storage root and code hash. So the storage root is the root hash of account storage. So for externally owned accounts, the storage root and code hash will be empty. This will not be there. An externally owned account is just like a bank account. It just has coins in it. So it will have a nonce and it will have a balance. What is the use of the nonce? I will come back to that. And then this storage root and code hash, these are non-empty only for contract accounts. So when you install a smart contract on the Ethereum blockchain, the smart contract will have some address, and corresponding to that address there will be a state, and the EVM bytecode of the smart contract will be stored in this. That is, the hash of that will be stored here, and you can retrieve it from using this hash. And a smart contract also has state, like variables. We will see some examples of what kind of state can be maintained. So those state variables need to be stored somewhere. You create another Merkle-Patricia trie, and you store the root of that trie here, the storage root. So these 2 fields are empty for externally owned accounts, but for contract accounts they will be non-empty. And here in the account state, only the hashes are stored, and then there is a key value database which the Ethereum node will maintain. By node I mean the client software, and if you give the hash, it can retrieve that the corresponding code, the pre-image of this hash, and using the storage root you can retrieve the storage variable stored in a contract. And each account has a 20 byte address. For the externally owned accounts, which are just like regular bank accounts, it is the rightmost 20 bytes of the Keccak 256 hash with the public key. For the contract address is the rightmost 20 bytes of Keccak 256 hash of the sender address and the nonce. So first of all, what is Keccak 256? It is another hash function with 256-bit output. They used it because it was the next specification of secure hash algorithm. So Bitcoin was created in 2007-8. At that time, the 3rd version of secure hash algorithms had not come. By the time Ethereum was being proposed, SHA-3, the 3rd secure hash algorithm standardization was happening, and Keccak was one of the finalists, so they picked that. But then what happened is that at the end, when the SHA-3 was standardized, they made a small change to Keccak, and they called that SHA-3. So the Keccak which is used in Ethereum uses the pre-standardized version of SHA-3. Now why is the contract address the hash of the sender address and the nonce? So we want contract addresses to be unique. Even if the code is the same, every time you install a new contract, we want the contract address to be unique. So they said that okay, the sender, the one who is going to create the contract, their address will be hashed with the nonce, and every time a transaction is sent from an address, the nonce is incremented. So this nonce starts with the value 0. Every time an address sends a transaction, the nonce is incremented. That I will show in the demo also, like how that works. Okay, so let's come to the smart contracts. So Ethereum contracts, the phrase smart contracts is a misnomer because they are not smart, they don't have any AI or any extra features, they're just programs, and also they're not contracts because they're not legally binding. So you cannot say that just because you have a contract on Ethereum that it holds any features of a contract. By contract typically we mean some kind of, it has some legal value. It's just a collection of functions in state at a particular address. And the contract logic is stored in EVM bytecode, like I said before, and you can look at this www.evm.codes. It has a list of all the EVM opcodes. I am not showing it again in the interest of time. So the contracts themselves are it's very rarely people write in EVM. It's like writing assembly language programming. People usually write in Solidity or Viper, and then the respective compilers compile it to EVM bytecode. So the contract has three things: state variables, functions, and events. So here is the simplest contract where you can create a currency. Let's go over the different parts. First, there is a pragma. This is a contract which is written in Solidity. As you can see, Solidity looks like C. It is a curly brace language. It actually looks a lot like JavaScript. And this was done deliberately because JavaScript is one of the easier languages to learn. So if the smart contract language is in user friendly or a developer friendly language, it will get more adoption, but that people realize in hindsight. So the pragma just says that what is the version of the Solidity compiler this contract will work for. So this says that anything above 0.8.17 is okay. This caret here means the above this version number. Then you have a contract. Think of the contract like a class in other languages, and this contract is called coin, and it has some functions here. It has a constructor, it has an event, and these are the state variables. Okay. So the state variables are this address means some 20 byte value, public means that it can be read, this address can be read from the outside the contract, and it can be written to also. Actually writing to that is not allowed. It can be just be read. Public just means it read, and this also means it's a public variable. What is this balance is? It is a mapping from an address to an integer, unsigned integer. Uint is unsigned integer. So these are the state variables. So what is going to happen in this coin example is that we are going to create a new coin, which will, and we'll hold balances of those coins, and we need a mapping from the holders of the coin, addresses and how much balance they are holding. And then there are these functions. There is a constructor which will be run only once when the contract is initiated, and then there is a function called mint, and there is a function called send. And then there is an event which is you can create events to help front ends like web UIs to respond to events. So suppose I send some coin to somebody and I want a web application to respond to that is okay, wallet updated or something. Then it will look for events. So the web application has to be connected to an Ethereum node, but there is an efficient way to read events from the Ethereum transaction log. So the first part is so you have this variable called minter here, address, and then the first part is the constructor will run only once, and when constructor runs, this minter variable is assigned to something called message.sender. What is the message.sender? Message.sender is the address of the externally owned account which created this contract. So whoever installs this contract on the Ethereum blockchain, when they send the transaction to create the account, their address will be stored in this message.sender because it will be sending a transaction to install the account. So this minter gets that value. Then every time you want to mint the coin, you specify two values, an address of the receiver and the amount. So this function checks that the person or the entity which is sending this mint So to do this transaction mint, I have to send a transaction. So this logic checks that the sender of the mint transaction is actually the message.sender. If it is not, then it will return. So the reasoning is that only the person who has created the contract, they can mint new coins. And what does minting new coins means? You have a receiver address and there is a mapping. So you just, in the balances mapping, at the receiver address you increase the amount of coins. And public functions will form the contract interface via the message call. So this is a public function, so I can call this mint function from outside. Again, I have a demo which I think I have enough time to show that. So private functions and variables cannot be, it's like other languages, they cannot be there, they are visible only in the original contract but not in derived contracts. So sending, so once the minter has sent, increased the address of a receiver, now that receiver can now transfer the coins to other people. The way you would do that is the send function, it has a receiver and an amount as arguments. If the balance of the message.sender is again in this case the person who initiated this transaction, if their balance is less than the amount they want to transfer, it will exit, otherwise it will update the balance and emit an event. This emit event is this from to and amount. So once somebody is allotted some currency, it's minted, then they can transfer currencies to others. They don't have to be the minter to transfer the currency to others. And like I said, the event is emitted to enable light clients like mobile applications to find this particular log. They don't have to sync to the whole blockchain. So let's do a demo of like smart contract deployment. So I'm going to be using something called Remix. Let me switch. So it is available at remix.ethereum.org. So what I have done is that it's a little small, let's make it bigger. I've copy pasted the, I've created a file called coin.sol. I copy pasted that coin contract from the Solidity tutorial. So the Solidity language, there is a tutorial you can find online. So from the initial tutorial I have copy pasted that contract here, coin.sol here. And Remix is it's a integrated development environment for Ethereum which runs completely in the browser. There is a desktop version also, but there is one which runs in the browser, and we are just using that because there is no installation required and I can show it easily. So this is the same contract except for some differences. So in the, because I wanted that contract in the slide to fit in a single slide, I had not done this part, this error variable I had not declared, and this logic was not there. Apart from that, it is the same as what is in the slide. So let's compile this. So this is the file explorer tab. There is a search tab and this is the compiler tab. Let's go there. Here it is showing me the compiler version and says you want to compile this. Sure, let me compile this. It compiled without any errors. Let me introduce an error to see. Let's say I do this. If I introduce a typo there, so it is saying the type error, member sender not found, not visible after argument dependent lookup something. So let's undo this and compile. It compiled, so it's fine. So here the tick mark showed up, which means it's compiled. Now I want to now install it on the Ethereum blockchain. So how do I do that? So I go to this deploy and run transactions tab, and here there is some selection here, environment. Here I am going to choose something called injected provider MetaMask. I'll choose that. Then immediately there is a pop-up which is showing up. So what this MetaMask, I think it was included in your prerequisites to install. So yeah, I'll unlock this. So this MetaMask, it lives as a browser plugin in my browser, this Firefox browser here. So what I have done here is that I have connected it to the Gurley test network. So this is the network selection tab or drop down. There is Ethereum mainnet, then there is some other testnet, but I have connected it to the Gurley testnet because that is the Ethereum testnet which is operational right now. And if you notice, there is an account here, and I have some Gurley ETH. Again, this is testnet coins, not worth anything, but you need this to do deployment on the test network. So I'm going to deploy this contract coin.sol onto the Gurley testnet. And when I change this injected MetaMask, it asks me to unlock the MetaMask thing. The first time you do this, it will ask you for some permissions. I've already done this, so it didn't ask me for permissions. But the first time you change this remix environment to injected provider, it will ask for some permissions. And here if you see, there is something called account, and 986 has been some populated here. If I go to my MetaMask again, there is 986. So it is the same, my account has been read by the remix application. Okay. So let us deploy this. Okay, let us deploy. So I just click deploy. Again MetaMask pops up, and it is asking for, it is saying contract deployment, and it is going to ask me to pay some money, which is still testnet coins, but it is going to cost some money to deploy this. So it is saying estimated gas fee is 0.00111035 Gurley ETH, and it is very likely in 15 seconds it will succeed. Do you want to confirm this? So I am going to confirm this, and if you see, it's like the transfer is going from account to a new contract. So I am going to confirm this. Then there is nothing happening here, but let me open the terminal again. So it says type the library name to see available commands. Okay, creation of coin pending, view on Etherscan. Let me go to that. So it's saying that the transaction is pending. Let me make this bigger. So the deployment transaction, I want to deploy this coin.sol onto the Ethereum testnet. Then this transaction is being deployed, but it is not been mined by the any testnet miner. So it is stuck in process. So it is like it is pending. Then in some time it will eventually get created. But if you see this 986, this is the address from which the transaction was sent. Let me go here. I think it is mined already. I don't know why Etherscan is saying it's done already. So it has been mined in block this, transaction index 9 and so on. Let's see. So let's see if I refresh this, it's been mined. So block number 813313, 3 block confirmations. Maybe the UI was just slow. So it has been mined, and so let's go back to remix. So now under deployed contracts, you should be able to see this remix, this contract has been deployed. So if you recall our that contract, it had 2 public functions and 2 state variables. One was minter, one state variable was minter, the other was balances, and then mint was a function which would create new, which would create will mint new coins for a particular receiver address, and then send is that sender can now send coins to other people. So let's do minter first. When I click on this, this is basically reading the variable, and I am getting 986135. That is the address of my account. So the address of my account 986 ends with 00C5, that is showing up as the output of minter here. Now balances, I need to provide a balance. Let me see, if I provide my own address, it will say 0. But let me switch my account to another account which I have. Copy that and mint to that address. And but mint has 2 arguments, one is the address and the other is the amount. Let's say I mint 100 coins and I say transact. It says some error. Oh, okay. The error is because my MetaMask is connected to an account which has 0 balance, so it can't send that money. So let me switch back to my account which has some money in it, and now I will try transaction. Transact. Okay. Again MetaMask has popped up and it is asking for permission to spend. So the reason it is asking for permission, there will be a permission here somewhere, is that in the real Ethereum mainnet or real Ethereum network, you're going to be spending ether to do this deployment and doing these transactions. All that costs money. So if Remix were to just launch transactions without permission, you might end up losing a lot of money. And you also want to know how much money a transaction will take, so it is giving you an estimated gas fee. That is, it's going to say this much gas, and this is it is denominated in ether, of course. Now if I confirm this, then it will mint 100 coins to this address. Let's see. So it says again, it is view. It says view on Etherscan. Let's go, and it's pending, but let's look at what the transaction is. So it says the function is mint, and it has two arguments, to and amount. Let's decode the input data. If you see, the to is address is, this is the address, which should be the address of my second account, and the amount I am minting is 100. Okay, so that is the and let's see, I think it is, and the from of this transaction is my address from which I created the contract, the minter address, and then I am sending, this is the contract address to which the mint transaction is going. So then this transaction has succeeded now, it has appeared on this. Now let's go to Remix, and in balances I will paste that same address again and check balances. It will say the balance is 100, and so on. So then you can do sending also. Now the sender can be now the person who has 100 coins can send. I don't have ether in that address, so I won't be able to show that demo. So this is the general workflow for Ethereum contract deployment and interaction. So any questions on this? Okay. So the way MetaMask works is that MetaMask is just a browser plugin. It is not running an Ethereum node, but in the backend it is connecting to something called a node provider. So how is the transaction, even the contract deployment, reaching that node provider? So MetaMask is actually owned by a company called Infura. They will, this MetaMask, whatever the transaction, once we sign it using our wallet, it will be sent to Infura, and Infura is running Ethereum nodes, and Infura will send it across to the Ethereum network. So that is how the stuff happens. Suppose you don't want to use MetaMask and you don't want to use a browser plugin. You can, here I connected to MetaMask because it's convenient, but you can also connect it to a like a local, I don't know why, like an external HTTP provider, or there should be a local one also. Maybe the browser cannot connect to that, but you can run a Ethereum node on your local machine, on your laptop, and then you can send transactions using that laptop also. Okay, so there are more examples on Solidity. So this is just a simple example. You can see more examples at this soliditybyexample.org. But what is in an Ethereum transaction? I'll just quickly end with that. So the Ethereum transaction has these fields. So let's look at these fields. It has, so there is an init and data. So there are two types of transactions, contract creation and message calls. Contract creation is when a new contract is created, like we saw coin.sol was created, and message calls is like the minting when your methods are called. So the init data, contract creation calls will have the EVM code in the init field. So it is a variable length field, and execution of that EVM code will be executed, and whatever is returned when that code is executed, that will be installed in on the blockchain in the code hash of that particular address. And message calls, like mint was a message call, it will specify the arguments of the particular transaction. And this RS values, they are like an ECDSA, they are an ECDSA signature. ECDSA stands for elliptic curve digital signature algorithm. And the V is used to recover the from address using R and S. Notice that here there is no from address, there is a to address here. All these fields, there is no from field anywhere in the transaction. So how does the transaction is just like a packet of data. How does the receiver know who is sending this? But to prevent tampering, this transaction will be signed by the sender. But you can recover this sender's public key or the address, Ethereum address, using this V field. And this nonce is, it is a number of transactions which are sent by the sender address. So it starts from 0, and you can you'll get a it keeps increasing. So let's look at the nonce of my account here. So here view account on Etherscan. Etherscan is again a blockchain explorer. So this can I see the nonce anywhere? I think it elides the nonce because most users don't care about that, so it's not showing that. So let me see, does a transaction have the nonce? Okay, yeah, it has like nonce 35. So this the nonce value is there, but it's like hidden somewhere. And the important thing about the nonce is that it prevents transaction replay. So the main difference between Ethereum and Bitcoin, or a major difference, is that Ethereum uses something called the UTXO model for storing coins. So think of them like they're like cards on which coins are stored. You can once you spend a coin, that card is torn and thrown away. But Ethereum uses an account model. So suppose I have a transaction where I'm transferring coins to my friend. Then I sign a transaction, say that from my account, please transfer coins to this other account. Now what prevents somebody from copying that transaction and replaying it again and again? Because the transaction has a signature authorizing a transfer of coins. So what prevents somebody from replaying that transaction? So the replay of transaction is prevented by having this nonce of the sender. So that keeps changing every time. So even though I have signed a transaction previously which approved a transfer, for the next transfer that nonce will be different. So the same signature will not work. I'll have to re-sign to approve another transfer. So when you have an account model, you need some kind of protection to prevent transaction replay. It is like, suppose I do a Paytm transfer and somehow that packet of data which goes to Paytm, if that can be replayed to the Paytm servers, then an account can be drained. So nonce helps in Ethereum, the nonce helps prevent transaction replay. The first transaction has nonce 0, and after that it keeps getting incremented. It's just an integer. Then there is this fields called gas price and start gas. So this gas was showing up there. So Ethereum, every operation in Ethereum costs something called gas, and you can look at the gas costs of each operation, like addition costs this much gas, SHA-256 costs 3 gas I think per byte. And Ethereum has instead of a size limit, Bitcoin has a 4 MB size limit, but Ethereum has a 30 million gas per block limit. And the gas price is, so the protocol cannot denominate the cost of an operation in Ether itself, because the value of Ether, the price of Ether keeps changing, and in the protocol I can't say that this operation costs some 0.001 Ether, because then if the price of Ether goes up, then the operation may become expensive. So the way around it is indirection. So you have a unit called gas, and the gas price keeps fluctuating according to the price of Ethereum. And sometimes you don't know how much gas a transaction will consume, so you specify a maximum gas limit. You say that I am willing to pay this much gas, and beyond this allow the transaction to fail. So the start gas and gas price are those values here. So the gas price times start gas way will be deducted from the sender's account, and any unused gas will be refunded to the sender's account at the same rate. So whatever is not refunded will go to the miner. So the gas, sometimes transactions can fail, and when transactions fail, failing transactions will also consume gas. It's not free to have failing transactions. They consume gas, and the miners will collect that gas as the fee. And the 2 and the value are straightforward. There is like for contract creation, you're just creating a contract. So this 2 is set to 0 bytes, and it is set to the null byte, which is represented in a single byte in Ethereum serialization. But otherwise, if you're sending some value or sending some Ether, then this will have the 20 byte address of the receiver. And for message calls, 2 will contain the 20 byte address of the contract, actually called recipient contract. Value is the amount of Ether you are sending. So value is the number of coins, you can say. So if you send coins to a contract, then it has to have a special function called payable functions, otherwise it can't receive, the money will just become unrecoverable. So you should be careful when you send money to contracts, unless they must have payable functions. Payable is a keyword. So that's all I had. So this is just a bunch of references on Ethereum. So I can take some questions now if you have any, otherwise we can break.
Even if the transaction fails?
Yeah, actually I should repeat the question, I forgot. So the question was that if you have a start gas, how does the start gas mechanism work? So I said that there is a start gas and a gas price. So start gas is the maximum amount of gas you are willing to pay, and you specify a gas price also. So the gas price times start gas is deducted from the sender's account and the remaining is sent back to the miner. Any other questions? Okay, thank you.